Well, this Rampage Twin Cat has got a few runs on it. I'm going to pull the motors and replace the bearings with ABEX 7 Boca bearing stainless steel units. First, I remove the motors. Simple procedure. I had to remove the coupler, of course. Now, I've been sponsored by Boca Bearings for many years, and what I got here is these ABEX 7 bearings. They're definitely better than what comes in our motors. Our motors have great bearings in them, but I put a lot of runs and dunk the motor in water a lot of times, so I'm gonna upgrade these bearings and see what kind of difference we get. First thing to come off is gonna be this front end belt. So I'm gonna remove each one of these screws with a 1.5 millimeter. Now that I've got those out, the screws put in a good place, I'm gonna remove these rear end belt screws. Okay, to remove the rear end belt, I'm gonna apply some force to the rotor shaft here. And push, and it pops out. You have to straighten your wires out and manipulate this end belt off. Okay, now I've got this rear end belt off. See a little bit of rust on the bearing. Still actually feels smooth though. Now to get this front end belt off, as crude as they may sound, I'm going to take a rubber mallet and tap on the rotor shaft. Okay, now I have this front end belt off. Again, you can see a little bit of rust. Now, while I've got you here, I'm going to explain to you guys the three main elements to a brushless motor. There's not much to it. You've got your rotor. This is a magnet, and you see these holes drilled in it. That's for balance. These windings around it, that's so it doesn't scratch the stator while it's spinning, and I'll show you. Or the stator doesn't scratch the magnets. These are the end bells and the bearings, as we already went over. Now, inside here is called the stator. This is where all kinds of wires are wound around. And how many wires are bundled together and wound how many times is how many turns the motor is, and that determines the kV. Now, inside of here is a steel core. That's the stator core. And that affects the magnetic field. Also, the gap between the rotor that's spinning inside and the stator itself, that affects the motor's performance as well. Typically, you want as little gap as possible because that way the core is really affecting the magnetic field. In fact, the motor can on the outside affects the magnetic field as well. So every little piece of metal that's taken off of the outside of this outside of this motor affects motor performance, and the thickness of this core in here affects performance. It's basically an electromagnet, and the more magnetic field there is, the stronger the magnetic force is going to be. And this stator is in three phases: A, B, and C. And the rotor has different poles on it. And as everything commutates, the ESC gives the phases different timing to make this rotor spin. There's more to it, but that's the basics of how this thing works. Now to remove the bearing, I'm going to place the end bell over a vise wider than the bearing diameter. And I'm going to hit this thing with my heat gun and heat it up. Then I'm going to pop it out through the center. Pop it out through the center. I'll sometimes use an old driver and a hammer, rubber mallet, and pop sheaves out very easily. Then I just simply popped the new bearing in. Aluminum and steel expand at different rates, at different heats. So the aluminum is going to expand more than the steel. So it's good to pop the new bearing in while it's hot. Doing the same with the other end bell as well. Now, heat works absolute wonders for removing these bearings from their end bells, but heat is also not a good friend to bearings. At the very least, what heat is going to do is kind of dissolve or loosen up the lube that's already in them. So hit them with some oil. Hit them with some oil while you have them off. Generous amount. You got the bearings nice and fortified. Let's reassemble it all. Your rotor in first. Bearing bell first. Make sure to get the rotor shaft aligned with the bearing and manipulate it on. As tricky as it may seem, you're going to line these little holes up. Bell is pressed on, holes are lined up. Sometimes if the holes don't line up perfectly, you can stick the end of your wrench in the hole and kind of wiggle it a little bit to get it right. Or you can take something and actually tap the edge of the end bell vent and it'll make it turn a little bit. Then replace the screws on that rear end bell with your 1.5 millimeter wrench. Put them in tight, but whatever you do not strip them. That's when things become miserable, is when you strip the end bell screws on a motor. You're going to replace your front end bell. That's going to be easier to line up on the shaft and align with the screws. It takes a little bit of manipulating to get it to go in, but you will get it. Again, a rubber mallet or a tap hammer can be of assistance in gently tapping your end bell in. You don't want to bang anything too hard because you will damage it, but tapping things will work. And your heat gun will be your friend as well. Now, every brushless motor has a bit of quote-unquote play in it. That's the distance this shaft comes in and out here. It could be just a click. But before you open the motor, check how much play it has. And when you put it back together, it should have the same amount of play or any at all. Even just a click, because otherwise you may not have seated the bearings correctly in their end bells, or you might have gotten too wide of bearings. And that's it. Your boat is ready to install back in your boat.